Today I will cover one more topic, that is the pair t-test. Okay, paired t-test. So all the content are the same here. So I go to the pair t-test slide, right? So I will talk about the pair t-test. But before starting it, you have to be ready with your tool. Okay, so first of all, we have to understand the pair t-test. I think one sample t-test and two sample t-test we discussed well last some sessions, right? And now we talk about the pair t-test. As the name shows, paired. So what paired? We have to compare. Basically, t-test always compare something. And what it compares? The mean value, right? We know very well. It compare the mean value of the two group, right? Two group of the same respondents. Please look at that same respondents, right? Which is important. That's why we have to consider different type of a sample. So you can see. So we used pair t-test only when we have the same respondent, right? And we the observation like two times. Okay, example experimental study it can be there. So just like here before or after, you can take the example of any patient in the hospital, the treatment he or she took, right? So we can see before the treatment what was the condition of health, and after treatment maybe 1 month 2 month it doesn't matter. So after it, what is the condition, right? We should know, and we can easily know that the treatment is valid or not. It really affected the health of the patient. Maybe the health of the patient is improved, or maybe the health of the patient is not improved. Do you understand? So this is just I'm giving the example. Right, in this type of example we have to use. Okay, so practically what it will do, we can explore the impact or effect, whatever you can see, of the target variable on independent variables. So we have to select our target variable, or and we see what are the variables or features they are affected to them, right? Okay, so mostly we can use for the experimental type of a study, like a medication study, doctor hospitals, likewise, you can see. Or many more example in comes in your mind, you can do and you can apply, but based on the task. But you have to understand the exact test. What is it? It is a pair test. So can you see here pair sample t-test? So can you see time 1 and time 2? Practically it is good. So basically it works for the time. So suppose what was the health in the January, and after treatment, maybe February or March, the patient has been discharged. Just think. So after 2 months, what is the situations? So we have to compare that type of data. We have to compare the mean. So my students, is it clear to you guys? Anybody has question or query up to now? This one is clear. And assumptions. The rules. What are the rules? So normality is most important. I think you are very familiar with the normality. So normality we can check with the KS or maybe SW test. I discussed in the last some lessons. Okay, so if we have the categorical variable, right? Because you want to check like what are the male health effect, what are the female health effect. In that case, we can go for this rule, right? Otherwise, if we have no categorical variable, only you can check the normality function. I think, is it clear to you? So this is the basic of the pair t-test. Okay, so can I go next? Is it clear? Let's go to the next sample. I will take one case study very soon, but just we have to fresh up our theoretical concept here. So pair t test, can you see here? So how we can calculate it? You can calculate it by pen or pencil. You can take it and you can use calculator, whatever you want to do. It is your choice. So just I have given some samples over here, some data. That is the pre-post design. Just this, it is only example. So suppose these are some persons ABCD over here. Before medications, this is the value. After medication, this is the value. So we have to find the difference first, D, right? Can you see? So x2 minus x1. So we can find this value, right? So this is the mean difference actually. This is the mean value likewise. So sigma D by N. Can you see? You can easily calculate the difference, 16. So our focus should be on that value calculation. If we are able to calculate the exact difference score, then we know that that is the pair sample t-test. So finding this 16 value or something like that, it is not enough. It is not enough. Why? Because we can see it is a difference, but we have to prove or we have to validate our result. This is the basic formula or way to calculate the pair sample t-test. My focus should be on that mean difference finding, and after finding we will see how to do it. Okay, so the basic formula of t statistics, yes, obviously we have to also calculate the t statistics. So formula is t statistics is the md minus mu d and smd. So smd is noticed like a same standard error of estimation. So here s is the variance and n is the population. If you will do the square root, you can find that value, and you put in the below here, so you can find the t statics. So this is the way, this is the formula, but you can do and you can calculate later on. But you know, we are using the tool SPSS. This one is, so I will perform on it. Okay, so I think you also have that one. I think it is clear. Can I go next? Okay, so case study. So I try to give example with some case study. So any, first of all, just try to understand the problem or case study. Then we have to formalize our hypothesis or our objective or task, whatever. Okay, so can you see any university, maybe ABC University, whatever the university, so there is no mention particular name. They conducted a one special program, that is the faculty development program, right? That is a FDP, like a workshop on one segment of the teachers, because they wanted to uh, improve the skills of the teachers. The university wants to measure the change of the attitude, right? What are their behavior? What are their thinking? What are their attitude? What are their mind, right? So they wanted to measure that one after FDP, right? So for this purpose, it has used a well-designed questionnaire, or maybe some questions have been asked. Okay, so how many questions they ask? So 10 questions they ask. So it is not mentioned here, just we are dealing with the data only, right? So question can be anything like, how do you think like uh, uh, you are improved? Okay, and answer was on that scale. Do you know the scale? 1 to 5. So 1 mean to say strongly disagree and undecided likewise. And the 5 mean to say the strongly agree. So like a 1, 2, 3, 4, 5, these are the scale. Basically, mostly respondent fill up that one. You can also choose by 1 to 10, it is your choice. But in this example, 1 to 5. This is the like a type of a scale. Okay, so university selected a random sample of 20 teachers. Okay, so did you understand the study? It is very simple case study. So our objective is to be check out what are the attitude actually. Is there any difference or not? Is there any impact of the FDP or not? So I want to check impact is there or not. If there is a good impact, so decision of the university management should be like that. They should go for a more FDP because it really helps to the teachers. Okay, so try to understand the concept. So in that case, I can make a hypothesis. What hypothesis now I can make? There is no significant impact of FDP on the teacher's attitude. Okay, what is this one? This is the null hypothesis. So I already we have to assume no effect or no impact. Oppositely, we have to make a alternative hypothesis. So it means to say there is some impact or effect of FDP on the attitude of teachers. So this problem is clear to you. So we have to formalize the problem first using hypothesis statement. Is it clear? Should I go next? Okay, so let's start the pair sample t-test. So how we can do it? It is important. So first of all, we have to check the assumptions. Which assumptions? Normality, right? And how we can check the normality? If you remember, how we can check the normality? Where I should go? Analyze, descriptive statics, and somewhere explore, right? Okay, I want to check the normality of the data. You can check for the both variable because both are the scaled variable, right? And these should be on the dependent list. So once again, try to understand again the data set once. Have a look. Before the FDP, it was the mean score basically, right? Can you see here? So after FDP, there is another value. What are the mean score or what are their attitude? Numeric value here. You can see before for this person, for this teacher, like, so how many teacher we have? I think 20 teacher around, right? So 20 teachers, right? So can you see the first teacher? The attitude is increased from 22 to 35. I think all the teachers has the same some increment, like someone has more, someone has a less, right? So in this 20, I can see from this data, we can easily see that there is some increment. Attitude is increased somewhere. It is not decrease every teacher. It means to say, it seems from the data there is some impact. There is a difference. It is we can see from the from this value, but we have to prove it using some statistical test, right? And we are applying the parametric test. And parametric test always assumes some assumptions. So first assumptions I told you, because here we have a not categorical variable. If we have some categorical variable, we can put here in the factor list, right? And if we put in the factor list, so we can also apply the second rule, that is the equal variance or homogeneity, if you remember. But in that case, we have no categorical variable, just leave that one, go for the normality statistics. Okay, so how we can check a normality? Just select here the normality plots or with the test, or maybe histogram. We can see by the histogram, we can check by the normality plot with the test. Go by the continue and do OK, and let's see what will be the result in front of us. Okay. Maybe you can also do it and check it what is the normality value. So I already use that data and I put some snapshot over here. So we have to check the same value. So I put some results over here. So I want to check maybe the same results comes or not. Let's see, because the same data we have. So this is the data set here. So 20 teachers there, and there is no missing value. We know very well some descriptive statics we have. There is some type of a little bit of negative skewness, it seems here. And after there, this is the first variable is before, second variable is the after. So also I can check here some negative skewness over here, but I want to check the normality exactly. Can you see here? So this is the value actually I found. So I can see this is like not basically significant. It is insignificant, right? If it is an insignificant value, mean to say the value is greater than 0.05. So 95% we can say that this is normal data, right? Before this variable, let's go for the second variable. Also, it is again the high value. It means the both variable looks normal. It can be proved from the here, the histogram, you can check it here. So it also show like some normal type of a curve, right? So check it. And I think second will be also for another variable. that is looks again a like normal type of a value. So there is, I cannot see like a mostly like any tail over here. So do you understand? Did you see that this data is normal? So but I will follow that table. So based on that table, we have to tell that the p-value is greater than 0.05. It means to say insignificant, non-significant, right wise. It means to say I have a normal data. We should not go for that. Okay, I cannot apply that test, right? So it doesn't matter that I cannot apply test. I can apply the test, but non-parametric test. So now I'm teaching you the parametric test. So next I can maybe next lesson we will discuss about the non-parametric test. So in this data, this data will be not waste, right? So this data can be used with another technique which has no rules or assumptions. I will tell you later on next time when we will see. But now we are focusing on the parametric test. So this rule is fulfilling here. In that case, I can see I can go with the t-test, right? Okay, another option can be also we can transform the data. We can change the data. We can update the data. Okay, so because there is some error in data, if there is no normal, so we can transform it. Maybe after finishing it, I will tell you how to transform the data. Okay, which is important. Okay, let's see. Let's try to apply our t-test. I think I can go next here. Let's start our pair t-test, which is important. So now I will open that one again. Can you see here? So where I can find the t-test. So always everything in the SPSS, this option analysis, because we are the analyst, we have to try to analyze the data. So compare mean. Can you see compare mean? There are a lot of options we have. So my target is to be now paired sample t-test, right? Click on it. Now you find this type of a interface. Okay, so first variable is first pair. This is my first pair. Can you see it comes over here? What is my second pair? Like group, just think. So it is there. So here you can also use the effect size because it is a latest SPS tool. We have some advancement over here, so we can also check what are the effect size. I will maybe you will, so you will see in the output we will see. And options, let's see, 95% we are sure, right? This is a CI value, confidence interval percentage. So 5% can be their error, but 95% you can also change this value, it is your choice. Okay, if we have some missing value, then you can select that option, exclude case wise. Other, because we have no find any missing value, so we can use go by that one. Okay, so let's go by the okay. Now the t-test result should be in front of us within a few seconds. So this is the peer sample statistics. Now we have to understand it. Okay, first of all, can you see this is the same method I put it here, and it will compare actually before and after, right? So from the first table, which is the basically the base table, paired sample statistics, like a simple t-test, if you remember, it will calculate a mean value, average value of the first group and average value of the second group. So before FDP, this was the mean score, and after FDP, average is increasing. It means to say we can see there is again a difference in average. So averagely we can say after development, after FDP, the faculty has going to be a high attitude. They are thinking, they are very positive. So decision can be good for conducting that one, right? So this is the way we can calculate it. So can you see here after value, which is the after value is greater than, right? This mean value of before is less than and mean value of after is greater than. So I can see difference can be seen somewhere, but we can, yes, it is also impact found, it is found. But based on this table, I cannot say, I cannot conclude that this is a difference, right? So we have to go for another table. Okay, so which is the pair sample correlation? Yes, it is the effect size actually. Do you know about the correlation? When I will talk about the correlation, maybe next time I will tell you what is the correlation. Correlation between actually is the some connection on some relationship between the two variables, right? Here I can see there is some connection between the two variables before and after some connections. The connection or relationship can be see over here. This is a correlation value, right? So there is some correlation actually, it seems, but it is not a strong correlation. I will talk about later on, but not now. So for the time being, try to see, I put in that table over here. So this is the actual p value, like again, right? It is again a is greater than. So it is not a significant. It is not a good correlation. There is correlation we can see because some value we have. But if value is less than 0.3, it means to say it is very weak correlation. Okay, if the value is zero point 0.6 above, then we can say this is a good, strong, or like a positive correlation. So it should be like a 0 0.6, 7, 8, 0.9. If it comes 0.9, it means it's a strong correlation. So positive correlation means to say as we are giving a good FTP facility, the attitude is going to be increase, right? So in a pair t test, this table is not important, but I discuss here. Now, the real statistics of the pair t test. Can you see here? So we have to use that statistics. Here you can see the mean difference. Obviously, I told you this is our task to calculate the mean difference. So there is a minus value. Minus it doesn't mean that it is a negative type of a correlation, negative type of a value. It means to say if you will do like that, this is like a x2 or this is a x1. You can find this mean value. So, but our task should be up to find that p value. So in this table, immediately you have to go for that p value. So you can SPSS is already telling me it is a less than value. If it is a less than value, it means to say it is like a some significant type of a value. So I put here that table again here, copy from there and put in the slide. So can you see here, this value is again a less than 0.05, right? And second thing, please see the lower and upper bound. Lower bound or upper bound of that mean value, you can see both value, uh, if it is a negative, both value should be negative or both value should be positive. Then the value can be there can be some impact. If this value is positive and this value is a negative, it means to say there is no impact. So in that case, we found both is negative. It can be also both positive. So in that case, there is impact. Also, we can also verify from here the p value. It is less than 0.05. It means to say there is some impact. Okay, so in based of that, I can conclude that there is some difference. Now, how to report our results? So report our results, we can easily see that on an average, faculty members has a bigger or good or great attitude towards their academics, whatever, before faculty development program, and then to after FDP. So we have to give this value over here from the table. So I put the table value after that one, right? So this is the degree of freedom, right? Because 20 variables we have to do the 1 minus T19, and this is the T statics actually, which we calculated previously here, right? This is the T statics value. Okay, the P value we have to report, it is a less than 0.05. So based on this result, I have to prove uh, that the null hypothesis which I considered, it has been rejected. It means to say there is some impact, right? There is some impact. It means that we have to accept our alternate hypothesis. So we have tested that one and we have proposed alternate hypothesis. So my main conclusion of the task, I found a some effect or impact of a FDP program on the teacher at that ABC University. So decision taken by ABC University for conducting the FDP was very good. In future, we recommend to do the FDP like that, so then teacher attitude can be increased proportionally. So pair sample t-test, I put a graph once again here. You can easily create a graph. One lecture I have given on the graph, how you can create a graph. You can easily create a graph. You can see this is a difference again, right? And how you can create a graph, you very easily mean difference. Okay, double click on it and you can do whatever you want. So here you can check, you can uh, create any graph over here. Okay, so you can delete this value, you can delete this column, and you can easily create a graph. Do right click or create a graph. Okay, it will create a graph for you. Okay, so please let me know. Can you see the same results at your system or not? This is the result actually. So here, what I did, I just finished the next pair t-test. So ANOVA and repeated measure ANOVA is also pending. I will speak on this test. Hopefully next session, I will finishing these all parametric test. Maybe I will also speak about the non-parametric test, which is important.